Okay, so now we're moving on to negative exponents and zero exponents. From last time or from last year, whenever it is, you should know x to the negative a, that just means that it should go on the other side of the fraction. Seeing as though it's over 1, if there's nothing down there, that means it ends up being 1 over x to the a. If it was already in the bottom, like 1 over x to the negative b, it needs to go on the other side of the fraction, so that means it moves to the top, and you just get x to the b on top. X to the 0. So here's an example when you would get x to the 0. If I have x squared over x squared. You know logically, if I have matching things on top and bottom, that's just 1. But from our subtraction rule, you know that would be x to the 2 minus 2. And we know that 2 minus 2 is just 0. So anything to the 0 is 1. That's going to be real handy and important for you to remember later. So let's do a couple examples just using that information. So 3 times 2 to the negative 2. We can go ahead and multiply 3 times 2, so that's 6 to the negative 2. We know negative means it's going to go on the other side, so that's 1 over. And you should know that 6 squared is 36. You should have all your squareds memorized, your cubes memorized up to 10. Some of the numbers like 1 through 4, you should know your 4th power is memorized. 2 all the way up to the 6th power. It's going to be real important to memorize your exponents this year. Okay, number 2, parentheses on the first term over there, so you're going to need to take care of that first. Negative 3 cubed. So 3 cubed is 27. If I have an odd number, 3, because of the cube, of negative signs, that's going to give me negative 27, x to the 12th, and I still have times 2x to the negative 7. Now that I've taken care of the parentheses, I can multiply the numbers, the whole numbers, negative 54, and I can add the exponents. X to the 12 plus negative 7 gives me 5th, and we're done. Number 3 is a distribution problem. So notice that inside the parentheses, they are not like terms. 3x to the 4th is not the same, it doesn't have the same exponents as negative 5x to the 6th. So you can't combine like terms, so the only thing you have left to do is distribute. So when you first distribute 2x to the negative 4th to the first term, 2 times 3 is 6, x to the negative 4th plus, or times x to the 4th, which means I'm going to add the exponents, gives me x to the 0. We'll leave it like that for now. Then when you do the next term, distribute to the next term. Notice the problem said minus 2 times 5 is 10. X to the negative 4th, x to the 6th, you're adding exponents. That gives me only 2 exponents. But we're not done. You're not allowed to leave negative exponents, and you're also not allowed to leave x to the 0. X to the 0 is just 1. That does not mean the whole thing becomes 1. This is 6 times x to the 0, so that means I just have 6 minus 10x squared. You have no idea how many people get that wrong on test day. If it's 6 times x to the 0, the answer is 6. If it's 27 times x to the 0, the answer is 27. So why don't you try that same idea on example 4. So do your distributing, see what you get. Press pause and see if you get the same answer as me. So after distributing, you should have gotten this far, but then you should notice you have a negative exponent, which you're not allowed to have. So, important thing to point out, the x to the negative 2 is only on the x. 6 stays there, and just the x squared goes to the bottom. Only the piece with the negative exponent moves to the bottom. And this piece over here is perfectly fine. There's your answer. Okay, so we did some basic ones, we did some with distributing, now we gotta deal with division. So the reason this is harder is because of the minus sign in the middle. You can't just start crossing things out on these problems. The reason this is a little easier than what we're gonna do in a little while is because of because it's over one term. There's no plus or minus in the denominator. That will make this a little easier. Because of that, you can put the first term over the denominator. So write it as 12x to the 7th over 4x cubed. The problem said minus, so still minus, and then you can put the second term over the denominator. 18x squared over 4x cubed. Now that minus is in the middle, and we can do each one of these the way you've been doing it since Algebra 2. So 12 and 4 goes into that 3 times, so this piece is going to be 3. 3x is on the bottom, 7 on top, so x to the 4th. Still minus, because that's what the problem said. 2 goes into both of these. 2 goes into that 9 times. 2 goes into that 2 times. So 9 over 2. I have x squared on top, x cubed on the bottom. So that's going to leave me with 1x on the bottom. And this is our answer. So that is an important part of an important problem that comes up a lot this semester. So I don't want you to try it again. Again, one term on the bottom, no plus minus in the middle on the bottom. That's what allows you to do this over that, and then minus this over that. So take a second and see if you can set it up the right way. So separating it out into 2 fractions over the common denominator, here's what we have. Then we can do each one at a time. So 5 goes into both of these. Will give me 3 over 2. Then we have negatives. So these 3 would go up there, but then those 5 would go down here. So it's starting to get a little tricky, so maybe I'll write it. X cubed ends up on top. X to the 5th ends up on the bottom. Let's go ahead and finish this one. So I have 3 over 2. That did not change. Then I end up with, when I subtract those, there's more on the bottom now, so I'll get x squared on the bottom. There's the first half of our answer. Minus, because that's what the problem says. 10 goes into both of those. Just 2. There's no denominator. All of those x's move to the top because they were negative on the bottom. So that ends up giving me 2 like we said. There's 7 up there. I'm moving 3 more up there. X to the 10th. But I should write it down here. 2x to the 10th. There's your answer. Okay, number 7. Please see the difference between number 7 and number 6. The fact that the denominator has adding or subtracting happening between the x to the negative 2 and the y to the negative 2 means you can't do that circle the top and bottom thing we just did in problem 6. So in problem 7, because there's a plus minus on top and plus minus on the bottom, you need to separate or fix each problem, each x to the negative 1, y to the negative 1, whatever it is, individually. So y to the negative 1 is 1 over y. The problem says minus. X to the negative 1 is 1 over x. All over. Y to the negative 2. 1 over y squared. The problem says minus. X to the negative 2. 1 over x squared. This is how this problem's rewritten. There's no getting around it. There's no shortcut. Now I can do fraction busters. We've been doing this for a while now. I look at the denominators. I see that there's y's and x's. More importantly, though, there's y squared and x squared. You have to use the largest common denominator in order to do this problem. So I need x squareds and y squareds. And every little tiny fraction, which if you look at this, there's 4 little tiny fraction, gets multiplied by that common denominator. So I'm going to write an x squared, y squared here. I'm going to write an x squared, y squared here. X squared, y squared, x squared, y squared. That's legal. Technically, I'm just multiplying by 1. I multiplied top and bottom by the same thing. Then I go through one at a time and I cross out whatever matches. So in that first fraction, there's a y in the denominator and there's y squared in the numerator. So I'm going to have x squared left, and one of those y's are going to go away and I'll just have y. The problem says minus. The other one, there's one x in the denominator, so one of those orange x's goes away and I just get x, but I still have y squared. All over. Same idea in the denominator. I have a y squared in the bottom, and I have an orange y squared on top. So all the y's go away, and I just have x squared. Problem says minus. X squared on top and bottom, those cancel out, and I just have y squared. But here's the next tricky part. This is not done. Very rarely are we done once we get to this point. Once you get to this point, a nice fraction with no negative exponents, you need to factor the top and the bottom. So if I look at the top, there's x's and y's that they both have. So as a GCF, I can take out one x and I can take out one y. So xy is a GCF. It gets written in front of the parentheses. When I factor out xy, that just leaves x for the first term. The problem says minus. When I factor out xy, that just leaves y for the second term. There's the top factored. You really need to recognize the bottom as a difference of squares. It happens a lot, and if you don't recognize it, it's going to make your life a lot harder. X squared minus y squared is just x plus y, x minus y. Doesn't matter which order. Now that I've factored it, you should see one of those factors matches. The x minus y is on top and bottom. I can cross it out, and my final answer is what's left. Please make note of this problem. It's real important that you can go back and practice this one and know how to do this one. And that's the notes for this section.